This video will get us through the basics of multiplication and division with signed numbers. We're going to start with a set of signed number multiplication problems. Okay, so the first of these is the multiplication you traditionally learn in elementary school. Both numbers are positive. You don't see a sign written there, but that's the math grammar. If you don't see a sign, it's a positive. So positive 6 times positive 4, and because you've done this problem before, you know that's just a regular old 24, a positive 24. In the next problem, we're talking about the same values, 6 times 4, and when you're multiplying with signed numbers, the values and the way that works remains the same. 6 times 4, the answer, the absolute value of the answer is 24, and negative 6 times 4 also has an answer that is an absolute value of 24. But because this is a negative being multiplied by a positive, the result is negative. We can think of these negative values, negative sign, as kind of a switch. Once you have one negative value in the problem, it switches to being negative. So here we have 6 times negative 4. Again, the answer will be negative 24. And the reason I bring up the concept of the switch is that when we have two negative numbers being multiplied together, that switch gets flipped twice. Or if you're thinking about perhaps the number line where it's left to right or horizontal, vertical, the direction of the arrow is being switched each time we have a negative sign applied. So a negative 6 on its own is negative, but then multiplied by a negative 4, we have two negatives, so we actually end up with a final answer, the result of which is positive. And this is true for even more complex problems. For example, if I have negative 2 times negative 2 times negative 2, I can come up with a value 2 times 2 times 2, which will be 8. The sign I will get by thinking of this as kind of a switch. Negative 2 is negative, times negative 2 again turns to positive, times negative 2 a third time gets back to negative. Now I'm going to pause and write you some division problems. Division follows the same basic rules as multiplication. The math is the same, the values are the same, and then you have to pay attention to how many negative signs are in your problem to the final answer, the right sign. So this is a 24 divided by 4, both positive. Again, something we learn in elementary school, so 24 divided by 4 is 6. Here, the division being represented by a bar is read from top to bottom, so I have 24 divided by 4. My mistake, negative 24 divided by 4, and that is the difference. There's one negative number in this mix, so the answer will be negative 6. A 24 divided by negative 4, again, a positive and a negative combined, we're going to have a negative result. And then if I have a negative 24 divided by a negative 4, my final answer will be positive, positive 6. And I could have a similar problem to that which I described here if I had, let's say, negative 27 divided by negative 3 divided by negative 3. Well, 27 divided by 3 is 9, and a negative divided by a negative would be a positive. So halfway through this problem, I would have a result of negative 27 divided by negative 3, 9. I'd keep this second part. 9 divided by negative 3, well, now we have a positive being divided by a negative. So one of each sign, and now our final answer would be negative 3. Now we're going to take a look at negative numbers with exponents applied to them. So talking about negative numbers with exponents, we're going to first look at these two expressions. They look very similar. We have a negative 2 in both, and we have an exponent 4 in both. However, this has a pair of parentheses that are holding the negative to the 2. And I'm going to illustrate how that plays out. Here I have negative 2 to the 4th power, which is this, negative 2 times 2 times 2 times 2. So the 2 value is repeated, but the negative sign remains just sitting by itself at the front. It is not included in the use of the exponent. Just to refresh, an exponent of 4 means you're going to take the base number, in this case 2, and multiply itself times itself 4 times. In this case, the negative 2 has parentheses, and the 4 is being applied to that entire expression. So now we're looking at this. Put some more parentheses just to keep it in order. I have negative 2 times negative 2 times negative 2 times negative 2. And this is an important distinction not to forget, because for this problem, 2 times 2 times 2 is 16. And the negative is going to still apply to the 16. But in this problem, negative 2 times negative 2 is a positive 4, times negative 2 again is negative 8. And then finally, negative 8 times negative 2 gives us a value of positive 16. So that parentheses makes a difference in the result. One final problem to look at, and this video will be finished. So the question is, will negative 1 to the 21st power be a positive or negative integer? And you can pause the video and give that a think if you'd like. To find the answer to this question, I'm going to look at the pattern. What happens as I start from an exponent of 1, which is the number itself. So negative 1 to the first power is negative 1, and move through with higher and higher exponents. Once I hit negative 1 to the second power, I'm looking at negative 1 times negative 1, which is negative times negative positive 1 for an answer. I'm using 1 because it's very easy. 1 times itself equals 1. It just keeps the same value. Negative 1 to the third power, negative 1 times negative 1. Well, that's negative and a negative positive. Times negative 1 again brings us back to negative. Here, negative 1 to the 4th power, negative 1 times negative 1. Well, that's positive. Now negative. Now positive again. So positive 1. And the final example here, to the 5th power, negative 1, positive, negative, positive, negative. So it ends as a negative 1. This really shows you how the negative number in multiplication is like a switch, kind of turning itself on and off. And you can see the first power is negative, the second power positive, because we have two negative signs canceling each other. The third power is negative, the fourth power positive. Again, pairs of negative signs canceling each other. And so then I can predict that negative 1 to the 6th power will be positive 1, because I know that the pairs of negatives involved in 6 will cancel out. 6 is an even number, so those negative numbers will be coming in pairs. Because of this, I can answer then the question, will negative 1 to the 21st power be a positive or negative integer? It will be negative, because 21 is an odd number. So I know I'll have an odd number of negative signs, and the very last one will be the one that turns the answer negative. Thanks for watching. Like me if you can.